let's first understand this. Do check the range. The range is 2 raised to 2 into 10 raised to 5. Okay. Meaning that, what is the worst case scenario of this loop running? So let's read the question then thoroughly. Given two non-negative integers n1 and n2, where n1 is less than n2, the task is to find the total number of integers in the range interval n1 to n2. By the way, can anybody tell me, before I go ahead with this question, there's an important maths concept here that I want you all to tell me one thing on, right? Somebody saying my second question was opening and closing kids, basically balance parenthesis. Yeah, that's right. Balance parenthesis is also possible. Yes. Do revise that. That's a good thing. Okay. Now, number of non-repeated digits. Before I come to this, can anybody tell me the difference between and what's the difference between these two, everyone? In this, what numbers are we talking about? And in this, what numbers are we talking about? Assume integers. First one include 1 and 5. Very good. So 1, 2, 3, 4, 5. And the second one doesn't include 2 and 1 and 5. Very good. So it's just going to be 2, 3, 4. Right? Super. Assuming integers only. Very good. So you remember your maths. Very nice. Okay. So the question is basically, task is to find number of integers in the range interval n1 and n2, where n1 and n2 are both inclusive, which have no repeated digits, meaning that it can't have like any repeated digits in them. Okay. For example, if I take n1 as 11 and n2 as 15, let's say I talk about 11 and 15. What are the numbers? 11, 12, 13, 14, 15. 15 is non-repeat. Non-repeat over here. This is a non-repeated number. 14 is also a non-repeat. It's 1, 4, 2 distinct numbers. Non-repeat, non-repeat. This has repeated digits. 11 itself is repeated, right? So we get how many? We got in this interval, the answer is equal to 4. 4 digits or 4 numbers which have non-repeat number. That is completely unique numbers. Only 4 numbers. All right. Did you all understand the question now? N1 and N2 will be given. You can also just check the constraints and so on. N1 and N2 will be given. And given N1 and N2, you need to find out. Given N1 and N2, you need to find out how many numbers are there with non-repeating numbers. Okay. I'll take the input. It's just taking N1 and N2 as input. So I'll just take the input. You all tell me what's the approach. How will we go about solving this? So this is as simple as taking the input. That's it. What is the logic? What is the approach or logic over here, everyone? What would be the approach or logic over here? Go from N1 and N2 and check whether it is a repeated digit number and increment count. Okay. How will you check if it's a repeated digit number? So somebody saying the most basic thing is basically, run a loop from N1 to N2 for each number. Check if number is having repeats. If not, then increase count. Somebody is saying using hash set, we can check the repeats. Okay. Somebody is saying we can consider them into strings and count the elements by using string.count function. If count less than 2, then check c is equal to c plus 1. Somebody is saying convert number into string, check whether str0 and str1 are equal or not. Very good. So you're all on the right track. One thing to remember, everybody, it's not always going to be a double digit number. It could also be something like 100 to 200. You have to find out. So you will have to find out all the number 101, 102, 103, 104, and so on. So 104 is repeat because 1 and 1 are repeated. 102 is unique, 103 is unique, and so on. So yeah, one way is you iterate a for loop, convert it to a string, right? Convert it to a string, and that string converted to a set. So how would you check for repeats itself? If I have to check for repeats, let's say 101, convert to string first of all. So I'll convert it to a string. make it 101, and also convert this string to a set. So that becomes 0 and 1. That's it, right? Those are the only two elements I get. Right? 0 and 1. That's it. This set has length 2. This set has length, sorry, this string has length 3, which will mean what? This means that it has duplicates. Otherwise, if they were all unique, then the set length and the string length would be the same. Understood, everybody, that this is one way to do it? This is the way we will check if the digit is repeated or not. Right? This is one way of doing it. There are other ways. Somebody is saying count for each digit how many times they are there. That's also possible. You can do that also. For each digit, count how many times they are there. That also you can do that, right? But this also, do you all understand this one? Yes, no. If you understood it, let me know. Yeah. Okay. We'll do the simple one first. We'll do this one first. Okay. And then we'll go ahead with some more stuff. All right. For I in range n1 to n2 plus 1, because I want to include n2 as well. I'll say, I'll convert it to a string. So I'll say word is equal to str of I, right? Convert it to a string. And, unique numbers will be, I'll convert this string to a, sorry for that. I'll convert that to a word. Right? Unique is equal to, sorry, I'll convert that to a set. Now I'll say, and let's say answer is equal to 0. We'll keep the count as 0 initially. If length of unique elements is equal to length of the string, that means that unique elements and the length of word is same, means that there are no repeats. Then I'll do answer is equal to answer plus 1. If it's not, then I don't do anything. I just go on to the next one. Okay. Finally, I'll print answer over here. Right, so it works out between 11 to 15, there are 4 such non-repeats. 11 to 15, there are 4 such non-repeats. If I run it, it passes also. Okay. Is this one clear, everyone? Is this one clear? Okay. Now, one thing to be kind of careful here is that this will work for TCS. This will never be an issue for TCS as such. But some of you are preparing for higher than TCS, right? You want to get into higher packages than TCS. So do you want me to discuss a little bit more about this question? Do you want to know a little bit more that because this, okay. So let's go ahead a little bit with that. Okay. Let's first understand this. Do check the range. The range is 2 raised to 2 into 10 raised to 5. Okay. Meaning that what is the worst case scenario of this loop running? What is the worst case scenario of this loop running? It's going to run 2 into 10 raised to 5, right? 2 into 10 raised to 5. It's going to run. Meaning that these operations here, you don't have much room for error over here. For example, if these operations, if the entire thing for each operation, let's say it's going into 100, then you're easily crossing how much? You're crossing into 10 raised to 7 territory. Remember, anything above 10 raised to 6 is problematic. So 10 raised to 5, and for each 10 raised to 5, you're doing 100 means it becomes 10 raised to 7. It's becoming problematic. Means I should be only doing at max as 10 over here. In fact, not even 10, probably 5 I can do over here. Because 2 into 10 raised to 5 into 5 will get me 10 raised to 6. Right? 2 into 5 into 10 raised to 5 will give me 10 raised to 6. But okay, let's give some concession and let's say you do 10. So it becomes 2 into 10 raised to 6. Still doable. Still doable. Okay. Can you estimate how much this will take? Can you all estimate how much this will take? Imagine you had to convert it by hand to a string. Here, Python is doing it for you. But if you had to really convert it to a string yourself, how would you end up doing it? You do it digit by digit, right? You'd end up doing digit by digit. So it means what is the maximum digit size over here? Can anybody tell me what's the maximum? How many maximum digits will you have? In these numbers, how many maximum digits are you going to have? In a number, what's the maximum number of digits you could have? 7. Okay, why do you say 7 digits? Why do you say 7 digits? Two into 10 raised to 5 is the maximum number I can get right over here. So the 10 raised to 5 is how many digits? 10 raised to 2, 10 raised to 3, 10 raised to 4, 10 raised to 5, right? And if I multiply 2 into this will give me, so this becomes 6 digits at max, right? This entire thing can be 6 digits, right? This is the worst, this is the highest number I can get, 6 digits, which means that it is 2 into 10 raised to 5 into 6. It is well within our, I mean, we will be able to manage the time complexity over here, correct? For those of you who are completely lost, don't worry, this will not come in TCS. You can rest assured, this is all, you're done. If you solve this question like this, you're done. You don't need to worry. I'm just discussing for the people who want to appear for a more difficult exam than TCS, then how would they end up solving it? So for this range, it works. But the moment I change the range, let's say I make it 10 raised to 10, right? That N1 less than N2 less than 10 raised to 10. This does not work out, right? I can't do this digit by digit, everybody. Can I do this? No, right? I can't do that. Okay. So if I can't do that digit by digit like this, then how would I actually go about solving it? How would I go about solving it, everybody? If I can't do this, I can't actually convert it to a digit, how would I try to solve it? Just some thoughts, everyone. We don't have to go to the exact algorithm, but what are some thoughts for this one? How would I go about solving it? Let's say my thing is something like between 1039 and between these two, how many numbers will be there which don't have any non-repeating digits? So how would we go about solving this? Any thoughts? Okay, I'll just spend 5 minutes on this. I know other people are thinking, sir, this is too complex and so on. Don't worry. I'll just spend 5 minutes. I'll not go to the entire discussion. I'll just give you a 5 minutes thought process on this, and then we'll close off. Okay. So do share any thoughts if you have. Every 10 numbers will have one repeated digit number. Yeah, that is one observation. That's a good one. Every 10 numbers is bound to have one. Okay, that's a good one. What else? But then you have other issues, right? So like, for example, if you start at 3 over here, so 3039 is always going to be, and then the entire 3300 series, for example, this was the original question, but the 3300 series, the entire thing is going to be repeated, right? Like even if you do 00, 01, 02, all of them are going to be repeated. Okay. Yeah. Okay. Think of it this way. I'll just give you the hint. Think of it this way. First of all, think in terms of how many positions you're trying to fill in. Okay. So think of it in that position, that number first, that way first. Okay. So, and your number of positions are defined by your, let's say, the last number, right? In that sense. So for example, if I just think of it like this, right? So there are 10 digits totally, right? So this is blank. This is what the number looks like, right? I need to go, technically speaking, I need to go from this number up until that number, right? This number up until that number, correct? Now, what are the possible candidates for this number? What are the possible candidates for this number? For the first number, what are the possible candidates? Okay, I'll show you. For the first one, it's not all digits, no, because I want to start here, right? See, if I start here, this is 9, I can't really go up till 1, right? I can't go up till 1. Yeah, we'll start with an easier number. Okay, we'll start with an easier thing. Forget that one. Let's look at this. I want to reach 130 and I'm starting from 5. Starting from 5. Okay, I want to reach 130 and I'm starting from 5. Okay, so the candidate for the first digit is, if I look at this, candidate for the first digit, you have two candidates, 0 and 1. You actually have two candidates, 0 and 1 over there, right? That's one thing over here, right? What are the candidates over here? For 0, you again have the candidate 0 only. For 1, you have the candidates both 0 as well as 1, right? So it could be 1 0 something and 1 1 something, right? Okay. When I'm, and then further going here for this 0 0, what are the candidates here? When it's 0 0, the candidates are only 6 7 8 9, right? So you have over here 6 7 8 9, right? These are the only candidates over here. Yeah. When it's 1 0, how many candidates do you have? You have all 1 to 9 candidates. And by the way, here you could have 2 also. I missed out 2. You could have 2 also over here, right? And you can in fact, yeah, you can go till 3 over here, right? So just making sure I'm writing all of them right. Okay. So in 1 1, you again have, all the way from 0 to 9. In fact, here also you have 0 to 9, right? In 1 2, you again have all the way from 0 to 9. And in 1 3, you again have all the way, you don't have all the way from 0 to 9, you only have 0 available over here, right? So this is one way to think about it. Okay. This is just one way to think about, how you're going to count it, right? See, because if it's 0 0, that means I got about 4 numbers here. By the way, 5 also is included, right? So 5 6 7. So I got 5 numbers over here, all non-repeating, no issues, because 0 repeating we don't really mind, leading zeros repeating we don't mind. So 5 numbers here. In 1 0, you're going to get 2 numbers, right, that are repeated. That means you're going to have 8 numbers left over here. When you're just talking about 1 0, oh, I missed out one thing also. It's 0, and you can again have the entire 1 to 9 digits over here, and again the entire 1 to 9 digits here, right? So it's a lot of thinking. You have to do a lot of permutations, combinations here. As I said, I just give you the hint over here, but the point is you have all 5 over here. Then again with 0, you can have all basically 1 to 9 over here, like 11 12 13 14 and so on. So how many is that? You have a bunch of them, right? Like you will have precisely how many? Like you will have 9 digits that are 9 numbers that are repeating: 11 22 33 44 55 and so on, right? So 9 numbers are going to repeat over here. So leaving those 9, how many are you left with? 99 minus 10 plus 1 would be 90 minus this would be roughly 80, I believe. Just a rough maths, you guys can double check it. Here it's 8 as we counted. Here for 1 1, none of them, because this 1 1 is already repeating, so that will give you 0. 1 2, again you have some 8 numbers over here, and this will be 1 number. So my estimation is right. You should have 16 17 22 102 numbers. Ideally you should have 102 numbers which are non-repeating over here. We can check that out also. Let's just put that here. Let's see if that is really the case. Is it saying 103? So I think we missed out one over here. I think this should have been 81 probably. Yeah, correct. 9 number. I counted 10, but 11 to 99 would be 9 numbers. Correct. So it would be 81, right? So that comes to 103. Anyway, so this is why I'm stressing so much on this is a likely an aptitude question for you. If you in your advanced math section in your TCS NQT, you are likely to get this in your advanced maths aptitude question, right? And over there, you can also do further some tricks and so on. But so how do you end up solving? Now we did here. How do you end up solving something like this? So this will not come for TCS. So I'll not go into detail right now. But for the people who want to go for high and advanced companies, think of this. Okay, it's a very good problem. How would you think of it? So try to think of it in this way, right? Little bit of DP is involved here. So for those of you interested in DP, little bit of that will be involved because you can keep taking from the previous digit how many were repeated and so on. So you can always get that. Okay. All right. So that's pretty much it then, everybody. That was all for today.